started.
So let me first share my desktop. So you should see some tech training window. If it's not the case, let me know. Let me move this one away. Okay, so the idea now is just to review a bit what we saw last time because of the long delay in between. If you wonder, I broke my spine, so I had to stay a bit at home. So what we saw last time is we'll just go quickly through the first page. So we saw ISG. What is it used for? Is to really give a policy on some subscriber. We have a lot of features that we can assign, and the features they go via some tunnel. And I would say, a tunnel not like the way we know in the configuration, but just imagine a tunnel where you apply a feature before you even hit the routing protocol of the ASR1K. So that would be what you do. Or is this tunnel handled by the ISR1K? Is because we install those features, we have a matching of the traffic to enter one or another tunnel. And then the last part in that ISG is obviously that we have a default path to send the traffic. So just to review, we had this IP subscriber learning at the interface. Once we learn the subscriber, we can actually apply a rule. The rule will apply all those features we're just talking about. So that was different type of initiating the subscriber or eventually learning the subscriber at the interface. And then let's check if I can actually go into presentation mode on this one. Maybe no, we'll just go down. Then there were some requirements to configure radius. We had also some requirement on a AAA because now we have subscriber services, and normally subscriber services only apply on the service that we will install on that subscriber. So there's a concept of service of subscriber. Service is really like a feature you apply on that subscriber. And it could be as simple as just shipping the traffic for some particular traffic. So you could imagine a customer provided for a subscriber multiple services, one for video where he applies some kind of shaping, one for internet traffic, maybe DNS is even another service because this is handled locally and he doesn't want to account packet for it, so he doesn't have any accounting feature in that service. So again, every time that traffic will traverse the interface, go to the routing, that's why ISG interact with the traffic of the customer. Let me go a bit down where I saw the different attributes for a radius. Or we can configure this in a radius with Cisco AV pair. In this case, for example, here we see that we're assigning an access list to the customer. This is actually something you could do even without ISG. You don't really need ISG. Some typical stuff for ISG would be probably with some name in the subscriber in the value of the Cisco AV pair and some accounting list and the name of the accounting list that you would eventually find in the iOS XE configuration. There are also some other attributes like this attribute for session timer or idle timer. This can even be used in a normal PPP termination. Again, you don't need to have ISG for this. Another advantage of ISG is obviously you can have an IP subscriber and kind of manage this IP subscriber like you would do with PPP, because you can give him specific costs, which you couldn't do before. ISG. So if somebody would really want to give some specific feature per IP, I guess ISG is a very good feature to do this. So let's go a bit further down. Here we also saw last time, this is typical for ATM, because if you want to do costs, again, not specific to ISG, you had to do some cost on the ATM interface to make sure you can have some feedback to the upper policy. But I don't think there's still much people using ATM right now. So specific costs that you can apply. Let me go down a bit. Where it's becoming very interesting is with the class. And remember the ISG, when you define a service, which is here, you see this, it's a type. So we first define if we have a type, or if we have traffic, or whatever. Here it's a type service, and we give them a name. Name that you need probably to find somewhere else. Maybe the customer configured it, but maybe he never really assigned it. Maybe he's using as a swap. It could also be that you find stuff in the configuration that are not really used at the time. But once you define the service, you need to define what's going to be applied on that service. In this case, we're going to apply this to some type of traffic. What is the traffic that we're going to match? It's actually defined in this class. And as you see here, it's traffic type because we're going to be handling the traffic. And here we have a traffic class default bandwidth. If we go to class map type traffic again, now we have the definition of what we actually call here under the service. And we have this name here that also obviously match. Typical mistake of customer when he configured the IG and then nothing works. If a mismatch, it does a typo in this name, the policy service will try to be installed on the customer. The ISG will look for this definition, it will not find it, and the user will flap back to his origins. Which means he's going to come back a little later. Eventually, you could even have a lot of high CPU because of this. But if you look into that definition of a traffic class, matching traffic, you have an access list. And don't be confused, the access list will not permit or deny the traffic like you are used to when you configure a router. It's just a match or no match. And remember, if you don't match anything, you fall back to the default. And if the default is not dropped, the traffic will go through. So potentially you can configure whatever you want. If you configure the access list that is here matching the traffic incorrectly, everything will go through unless you have put this, the default inode under the service, which would drop the traffic. But sometimes customers even forget that one. If you are sure the service stays alive with the customer, so for example, I have a subscriber in the airport and I redirect him. I also give him obviously a service to get the DNS because he doesn't know obviously the sites that I have in the airport, so he needs to resolve the name when he actually serves. So that service with DNS, I would actually plug it with default drop because I know he will always be there. Because as a decision in my topology, that service will always be with my subscriber. Maybe my next engineer that will replace me at the airport when I'm kicked out would decide that it's not needed and it would eventually still work because the internet service would still match it. But eventually the class default drop is disappearing at that time, and suppose later on his internet traffic is classified, or we put some access list so that you cannot get to some specific site. If it doesn't match that internet service, it will obviously not go through that tunnel if we think about the topology of tunnel within that ISG. But it will then go to the default, and default drop is not configured or not applied because he decided to remove my service DNS, then everything will still go through. So it's important that you keep in mind when you design ISG that if at some point you need to drop the traffic because customer is removed with a service or you need to apply some sequence, this one is still there. So you will see most of the customer, they apply it with the open garden automatically. And eventually the redirect service will only even have a input information. So input meaning coming from the subscriber. So looking at this here, I see that it will also add a feature in that kind of tunnel. So I was talking about tunnels, so let's draw a bit on this. So that you still understand what I'm talking about. If I look at this, my SG, so this is the big box, the router. Here is the interface. I don't know if I can actually probably do something in PDF. We even go there. So just to make sure we understand what we're talking about. So if this is my SG and I actually have talking about those tunnels all the time, let's change the color with some of the shape. And we actually put this here on the SG. This is actually the interface. Eventually, the interface would be an Ethernet. And for my subscriber, I have one tunnel. So if I imagine this tunnel for the subscriber, so this is just a definition of one subscriber, but I can have multiple tunnels for that same subscriber. If this traffic arrives here, let me put some lines on this. Shape, this one. Suppose this is my traffic arriving from the subscriber. I can decide if I'm going to go there, there, or there. The only way to decide is that the class type traffic eventually would match. So if I have a service that is here, that is my DNS, and when I assign that service, I automatically do default service, default drop. Whatever it doesn't match here, it will go into drop. If I then reassign a service for redirect, and eventually the redirect goes into the portal somewhere, oh, it goes here on the portal. Packet comes back from that portal because it hits the SR1K. It's still up to me to define a correct way to go back to the subscriber, again with that traffic class. So again, I can even do default drop in or default drop in out if there is some purpose for it. You will see most of the customer do in out by default. And then eventually that traffic that comes back to the portal, instead of hitting the service redirection, I could still forward it back through this tunnel. Oh, and imagine this is only for one subscriber. So as you could have a 64 times this, you know. It's a lot of installation of features and so on. And you know, the SR1K, it uses object to install all of this in the hardware. So we had some case when sending that information to the hardware of a SR1K, we have object lock, and then nothing works actually. Another stuff is that like 1 or 2 years ago is to send this in the new version of Polaris, you needed to have this boot advanced enterprise feature. And by default, it was not. It was IP-based. So this functionality of installing in the hardware was not supported in IP-based. So you had a subscriber looking at the control plane in the RP installed with everything, but there was nothing in the hardware. Nothing was working. So a bit strange because you see in the show command that everything is installed. So yeah, sometimes you have to think about this part of the hardware in the SR1K that will install something too. So here, this could be an internet traffic, and then Eventually, if it doesn't match DNS, it doesn't match the redirection, or maybe the redirection has been removed because we installed a service internet. So we only left with those two. Then traffic goes to the internet. Internet is then removed because I didn't pay. Customer remove it. He reinstalled the redirect automatically, and again the guy can go to the portal and play or pay with his a credit card some new amounts. Once it's installed, he actually removed the redirect, and he actually still leave the open garden because he decided this is actually the default drop. And then we remove this stuff. And then you reinstall internet. Another way also that you will see a customer doing is with prepaid. They install a prepaid, and when it prepaid, it defines it's actually traffic is exhaust. You can call the rail for redirect automatically without any interaction from a control plane to do this function that I just showed. So it's also a possibility in prepaid. So but this concept here is really important. Try to understand the direction of the traffic. In is always from subscriber. What do I choose as a pipe within that subscriber feature installed? Is it matching, or does it match with traffic class? And if it doesn't match, what does it do? Is it falling to the default? Yes, by default, but what is the default doing? Up to you to look at the configuration to find out if it's actually dropping, if the idea was to drop it. So that's the important part of being able to read that configuration here. So cross type traffic, we must share this ACL. ACL is not there here in this config, but we assume that since it's looking at the default bandwidth, it might be an internet service, because some customer will install default bandwidth service. Just if the guy didn't pay, he still has like 512K or something of possible to send some traffic at that speed. You have always something corresponding in the radius. So in the case you configure in the radius, you don't need it locally. Sometimes it's better to have it locally. Sometimes, since the customer is changing all those services all the time, it's better to have it in the radius. But again, customer decision. If you decide that even his DNS service he wants to have it in radius, there is nobody that can say he cannot do it. So here it was a way to auto log in the subscriber. This is something you will see a lot with PVP user also. As I was mentioning last time, if you have this in a subscriber definition on the radius, you might have nothing configured at all on the ISG side, ISR1K side, and but still it will be a subscriber actually. Its ISG will still be functioning in that machine. So sometimes we had some discussion with people sending it to outsourcer just because it was a PPP case, but actually it was an ISG case. So if we look at those different steps in a policy, the policy type control here is the one you call when you find out what type of user you have. How do you find out what type of user you have? Is with this IP subscriber command under the interface. That's where the subscriber enters. So suppose you have DHCP user and you trigger the session when you see this DHCP discover. Once you have learned that, you learn the subscriber, so you can apply some rules. If the rule fails, maybe the DHCP hack will never arrive to the customer, even though the server that is maybe behind this 1K will. So it's important to know what the DSG is doing. I've seen many customer opening cases with ASR1K doesn't send the DHCP hack. So case is routed to outsources because it's DHCP, but actually it was an ISG problem. And since the outsourcer was not even aware about ISG. So we never told him what it was. He was still looking at why the HTTP was not really sent to the customer or the subscriber. But after a few months, the customer got pissed, and then eventually he was recused. So, rules of a policy. First, we need a control to define the policy, and then we define a name. In this case, it's rule 1, but we could put whatever you want. You will see a class type control, so we need to control something. And here it's always the event session start. So it means every time we learn some new subscriber, because the always is there, and session start is there, we're going to apply what's below this line, actually, here. If the subscriber was already known, for example, we came once with the session up and he was doing the GP, so we learned it. We actually put the binding in the database of this ASR1K that is dealing with ISG. And then when this subscriber comes back, it's actually not a session start because we already knew him. So that will be a session restart. Some of the stuff that a customer will have trouble with, especially new install, because they're doing tests, and then when the session is clear because of an idle timeout or something like this, it doesn't come back correctly. And just because the events maybe are not configured correctly. So one more thing, I searched once a lot of time. Now that I'm thinking about, you have this under the interface, service port tab control. Some customer, I don't know how they do it, but they actually type it on the global. So they enter the interface and then they do some mistake. Maybe by doing the mistake, they fall back into global, but then they apply the service policy control under the global config. It's a line somewhere at the beginning as the config, and it causes a lot of trouble because if this rule is actually trying to identify a PPPoE, for example, but you didn't really define anything under that type control, the PPPoE will fail. All PPPoE session will fail. And we've seen a few times this. So customer, they're supposed to apply there. I don't know, it's because of pasting the command incorrectly or something like this, but they fall back to the global. They apply it in the global, then nothing works, and then they come back and see, oh, actually didn't configure it. So they reconfigure it once more on the interface, but then nothing works. So in that case, you will look for a long time. So here we were at the definition of those class type traffic with this concept of tunnel I was mentioning. You will not see this in the documentation, but I think it's a good picture if you have this in your mind of what is done on the subscriber. So next we can apply some service with some here a sequence, and remember, like I said last time, this is a priority. Why is priority important is because we can decide who needs to match first. Maybe it's really important because if you want to, for example, redirect traffic, and you know when the guy didn't pay, there is no service internet. So eventually the definition here with default bandwidth will not be there. There's only a redirect service and maybe some service for DNS and returning the HTTP redirect to the customer. But for the rest, we drop. So then once the customer has paid, you don't want really to remove the redirect, but you decide actually I will leave it there. But I will install internet, and internet service will be more or higher priority than the redirect. So that if it fails, I keep the redirect. It could be an ID. Then you could really play with this priority here. So put, for example, redirect as priority to 30. You put your DNS as priority 10. So if it's on DNS packet, you will always first match or actually first look in that service that is DNS, and then it check, okay, how much DNS, this is the one I have to take. You go to the DNS server. Then eventually, if it's an HTTP packet and you didn't have internet service, you will look again in the DNS service, but this time it will not match. So you will look in another one, which is the next one as a priority, which in that case would be eventually the redirect. In that case, you go and check and you match, you apply feature redirect, you return traffic, assuming this DNS service you had previously can handle the return traffic of the portal, the guy is being redirected. But now you install the internet, and you actually install with the priority 15, which is in between. So eventually, I could even put back this one so that we understand a bit better. So if I take here a priority, priority 10, this is my DNS. I have a priority 20 for the redirect. Obviously, I also have this default drop all the time, so I have to take care of it. I mean the default path. But this time I decide I will drop it, so I make sure that if I actually get the trouble or if the traffic doesn't match any of those, then I will drop it. So this is now default drop, and I will try to put some line here. So here is maybe some black line. So here are the traffic, and again, imagine this is per subscriber, this stuff here. So any traffic that will match the default will actually be dropped, so it doesn't go through the internet that is here behind this router. But so I have this traffic coming for DNS, it match, okay, it handle the traffic. I have this traffic coming from HTTP, priority 10 is looked first, so I will actually move through the priority 10. Let me move this one here. So, but I don't match in this one because I'm actually having HTTP traffic. So I go there, I match, I do the redirection with the server. Server returns traffic, and here I have managed to configure the traffic class so that the return traffic also matches HTTP. But first, it needs to go there, obviously. Then once the guy has done this redirection correctly, in my design, I actually decide to configure an internet service, but this time with priority 15. Does that work? We'll see if the idea is correct. So let's see now. I'm actually having internet service for the moment, so I should be able to reach there. DNS arrive. I have matched this kind of tunnel here. So I send to the DNS server, I come back. Now HTTP arrive doesn't match the DNS service. Maybe in the return, but eventually the return could also be specified with the address of the host. So I'm sure any other traffic from internet is actually not matching it. Then a traffic to Google doesn't match this one. It matches this one, yes, because this is actually my internet service, so it actually goes out. The redirect is still there, but it's never used until this one will disappear again. So if that one is removed by the customer, I don't need to reinstall anything. I have an HTTP packet. Is it matching this DNS? No. Is it matching the redirection? Yeah, because actually it's to Google and there's no internet service. So I redirect again. So you can play really easily with all those functionality and achieve a lot of stuff with ISG. So you will see those behavior where a customer play with priority. You will see behavior where a customer play with COA, which is a change of authorization sent from a kind of radius or a billing server or whatever that assign service, that remote service automatically to a subscriber while it's alive. So you can do a lot of stuff. with this. And you can, most of customers, they will actually, if they do redirection, remove the redirection service by config. So in the policy type control, you can do an event. If my service internet comes up, I'll remove the redirect. So you can do it locally. You can do it like I was explaining with the priorities, just inserting a service internet in between, removing the service internet when the guy didn't pay. Or you can even do with COA, send a COA to remove the dynamically the redirection, and eventually you install the internet service also with the COA. So to achieve the same stuff, you can do it already 3 different ways. But we're just talking about a simple config where we have DNS, internet service, and some redirection. Simple config for one class. So you will see some of the customer became very specialist, and they have like 10 or 20 different steps in that policy type control. And you really spend like 30 minutes to understand exactly what he wants to do with it, and then you spend another 2 hours to try to find which traffic is actually matching one, especially if you have like 64,000 users on it. So important to understand this matching of concept of traffic into a traffic class. So a question?
And one question. What's the default priority on this policy definition?
So the default, there's actually none. I would say if you don't have a priority, it's the highest priority. If you have 2 users with so suppose in the previous stuff here, you didn't configure this 20, because it's also possible. You type class type traffic and there's no priority. Or suppose the customer didn't configure this keyword here, which means that traffic class has no priority defined. That's the highest priority. Then if you put 10, 10 is higher, has a higher priority than 20. So just think about the case, CS1. 1 is higher, and then if you have 2, it's a bit less priority than the 1. So if you have a customer installing a config where he never configured the priority, regardless if it's local or from the radius, the first service install will have the highest priority. So same if you configure the same priority everywhere. So if you would configure here all the service with the exact same priority, is going to be depending at which time they actually installed by the ISG. So sometimes we have seen case, for some reason, it was working fine, and later on, for some reason, that service was installed a bit later, and then this config didn't work anymore, just because he had the chance before that actually what he wanted to achieve, his service was installed first. And maybe he had some delay in the radius or whatever, and then the second service was installed a bit later, and then the entire concept that was done by the SG before was inverted, so the thing was working. So, and same if you have twice the same value here, it's the first one that's going to be installed. So there's no real default. You have different priority depending on what you do. So,
But are you saying if you have priority 20 and priority 15, so the lower priority takes precedence, and then if that's satisfied, then it goes to the next priority?
Yeah. So this is what I was actually showing on that PowerPoint. So if you look at this, 10 is first, but remember, it's a match. Do you know, can you handle this traffic? No, it's not for me. Then he goes to the next one. Can you handle this traffic? Yeah, it's internet, it's for me. Yeah, I'll send it through. And then unfortunately, if this one was supposed to handle the internet traffic first, but you gave the wrong priority, it's never going to be hit. It's always going to be hit by this one. So it's important to also understand, especially when you start playing with traffic of redirection, and sometimes people have a misconception of the access list. First, because they come from a router configuration and they think ACL is there to drop or not drop the traffic. But here it's a match and no match. So if you don't match, you go for, obviously if you have the default drop here, traffic will be dropped, but maybe if you forgot to do default drop, traffic will go through. So that was a very difficult part for some of the customer first, especially not knowing ISG, and you do ACL every day, you say, okay, if I don't match it up, but actually it's not the case. Actually, even in ISG, if you deny on purpose in this tunnel, it will by default not match, but you could still match it here. And it's even more confusing then, because if you remember deny IP traffic any in an ACL assigned to an interface, nothing goes through. Here, suppose you configure it here and you say deny IP any, okay, this one will never match. And suppose you don't have those 15 and 20, you fall back directly to this one, but this one is not default drop, so everything still goes through. So it's important to understand this. And sometimes customers have some trouble, like I say, because they're coming from this world of iOS where you were just supposed to drop when it was denied. So that's the different service that you can apply. Think about those tubes inside the subscriber where you have applied some traffic, some feature. So you can configure obviously different type of service. The service activation, like I was saying, can be done by the auto logon. That's the A that is standing before that name default config that you see here. You can send this to if you send this to a user coming up on PPP, you don't need to configure ISG at all in the ISR 1K. Once the iOS XE will see the A and this Cisco account info, he will know it's actually an ISG subscriber, and he will treat that PPP session as an ISG subscriber. So even though in the config you wouldn't see anything of it, so it's still possible. The N over here is just to say I'm prepared to eventually assign that service. Why did they use it? Is because you can eventually go via portal and select with a button to click and enable some service. Then eventually that portal will send a COA and activate the service. But eventually, if that was wrongly configured in the ISG, at that time only you will find out it's actually not possible to enable that service on the subscriber. So by doing this N, the ISG kind of check it and tells the portal, yes, you can enable that service. And then when they click, they just send a COA. Or it's another way to give dynamically to a portal different type of service that you can dynamically configure in the radius, remove, add, and whatever for subscriber that you actually handle as a service provider. So dynamically, his page will change when this is not present. So in the radius. Normally, the portal also do a radius access to the radius service. So they just correlate stuff, but if ISG says, I don't have this, the portal will not show it in the page to the customer. So this is another way to do this. So we were here where we have this control, so we will control the subscriber when, always, and at which time, eventually, when the session starts. I was giving that example of the DHCP for sign of life. We try to authorize. We try to authorize what? Obviously, with the DHCP IPv4, there is no username and no password in that DHCP packet, so we have to kind of create ourselves, which means we need to create a username and a password because this is what Radius wants. Any radius will always want a username and a password to try to authenticate. That's all he wants to do. Once he has authenticated, he returns some attributes up to you to configure it correctly so that the ISG is doing what he wants. If it's not configured correctly, but is known in the dictionary of the radius will not check anything. So it's really you to control that information that you're going to give back from the radius. The only thing the radius will do is control if he has this attribute in his dictionary. If not, he will not even create it. So here we will authorize, and like I said, we'll create a username and a password because it's a DHCP user. So we have the password lab that we're going to use, and as a username, we're going to use remote ID, a line. So the username line will be remote ID plus circuit ID plus MAC address. The plus not actually introduced inside the username name, but all those values will. So with those dash in between normally. So now we have a very long username, and we have a password, so we can actually create a radius packet, and the radius packet will go to the radius server. Radius server will check, is it really existing, that username with this lab password? If he goes through his database and he finds out everything is fine, he will return an access accept, hopefully with some attributes. But maybe if you didn't configure it, you will not get anything. The guy will just be authorized. Is it a possible case? Yes. If the guy decides he just authorized the subscriber who will send all the service via change of authorization, that COA packet is still possible. Again, to achieve the same stuff, you could have like 10 different ways here. You could do an auto logon, you can do COA, you could remove services at the time, you can add services that you can only see really with the debug. Or if the customer gives you the flow chart of his, or the step that the customer will eventually take, you will be able to understand more quickly. Often the guy that is opening the case is from the NOC and he doesn't understand AG, so you will have to find out yourself by looking at debugs. Except if it's Swisscom. Swisscom, they will open the case, but when they already reproduce it in their lab. So here we have the step for authorizing. And then you will see those bigger config, where you really need to look at each component. And actually, ISG is always like that. Look at each step. For example, a very stupid stuff if you forget, because huge trouble is forgetting this authorization command here. Is a authorization subscriber service default. You don't define the default local, so even though you have configured all your services locally, you bring up the user. The rule one is to assign, I don't know, a DNS service, but since there is no authorization, ISG doesn't know what to do, and everything fails. And you look at your config 20,000 times, but you still forgot to look at this subscriber service, or you didn't thought about it at the time, and you will not be very successful. Even debug is difficult to find out. And if you don't enable the right debug, you probably would not even see it. If you debug only subscriber policy event, you will not see. You will see the drop, but you will not see the reason. In that case, you would eventually need to debug AAA. But at the time that you think about debugging AAA, probably you will think about the AA authorization. So make sure it's there. Always think about the step when you create a subscriber. First step, we need to learn the subscriber. Second step, we're going to apply a rule. If the rule has a service, we need to authorize the service, or the local or prior radius. But so that line needs to be there. In the ISG, maybe if you have this, it will try that one, but maybe that one goes to another group, so it will still fail. So could be, or you forgot the local first, and the customer has actually not configured a DNS service, for example, in local config. So as you try the radius, it fails. Since we even fail to install the first service, the session will drop again. So, and then higher probably higher CPU, and DHCP coming up all the time. DHCP will go higher in CPU because we have a lot of discover from end users, especially if he's testing this with the Nexia, and then you might have the wrong impression that your problem is actually a DHCP high CPU case. But actually, the only problem was probably this one. So always think about the step in the case of IAG. So again, first step, we learn the subscriber. And what is the type of subscriber it is. All do we need to learn is actually written within those two lines. As I said, class aware is not there anymore in, I think, from 15.5.3 or something, or even earlier. They removed this one because now DHCP is always class aware for IAG. So we learn that user, and for example, DHCP, we have the discover now, we have the MAC address of the user, so we can start installing information for that user. We also know which interface it came from, and so on. So we have a lot of information already from that user that is trying to bring up a session here inside the 1K. So what do we do with that user since we actually learned it? We do ISG, and we're going to control it with rule 1. The rule 1, it's easy. For who? For everybody, because we have always. So every event session starts. So every time we see a DHCP discovery in our case here, we will apply this one. Is it possible to have other ones? Yeah. Maybe always will be for something else. If you think about maybe you want to give different services in a company with ISG, and you have the developers, you have tech engineers, you have salespeople, and they all need to go somewhere else. Maybe they have different type of authentication mechanism because, you know, the sales wanted to be very independent and they have their own server for authentication and all that stuff. So you could eventually match here. Whoever has MAC address, whoever has IP address, you could do something else. And whoever has IP address range that, you could do something else. Or would you know the IP address? Obviously, not by L2 Connect this time, but routed. And then you would need to find a way in your topology to learn about this IP address. So maybe you need some back office between the DHCP server that would be on the front of DSG with some radius. If they can talk together, you know who has this IP address and you move it into a range. Or you could simply configure a DHCP on the front and assign MAC address statically in the DHCP server, so your issue is always having the same IP address. So all possible. Here we have an authorization like we saw before. So the first step to execute here is to authorize, and we authorize with the password and some username like we just saw before. What's happening? The AG is sending now a radius packet to whom? So that's the next question, because once you have configured this, what is it actually doing? And here you have an authorization list 1, meaning you need to go back to a list author 1, and this one is a network, even though you see it's actually kind of authorizing a subscriber because we're looking at the password and a username, but it's still network. So, don't use subscriber service for this because this is not a service. It's actually that subscriber that we try to authorize. And we send it to this group of server here, and here in this case is the same group. When you can see this config has multiple times the same group, it doesn't matter. I mean, if you want later, you can change it, but here you can actually always put the same group of server. So we send the radius packet to this guy here, 192.168.1.100. It arrives at the radius server. We're looking at username, at password. We go through the database of the radius somewhere. We just find the identifier that we actually send, which is remote ID, circuit ID, and so on. And you will send our access accept, but also a bunch of attributes. So here maybe not very clear to what you would see normally at the customer. You see that he's using a Cisco Attributes account info, a Cisco AV pair, and some idle timeout here for 28. He's returning the username again. It's not obliged, especially in authorization. You could see also this when the guy is doing a login, that they change the username. That's also possible by sending a new username from the radius, often. So in the case of we're going to send from a portal, you could have this case where your user first is known as an IP address, and then the same users change with a username, like I don't know, Daniel or whatever, 255, and you wonder where your username actually went, because it was first authorized using an IP address, and then when the guy went through the portal and that portal created the packet, he actually changed that username, and the ISG will adapt it. So sometimes it's not easy. So anyway, what do we return here in account list? So we will put a feature accounting on that subscriber, and here it's at the subscriber level. Then we will assign an auto logon for default bandwidth service, so an auto service, you could also call. Where is default bandwidth service? From this config, I don't know. Is it going to go to the radius? Maybe, but I see the local, so maybe the customer didn't give me the entire config. Is the default service picked up from local or picked up from radius? If I would get the case right now, I'm not sure. So I suppose I only have this as an information. So I need to ask the customer the full config to make sure it's not configured locally, especially if he's complaining a subscriber doesn't come up. If it's not configured locally, then maybe the problem would be a radius config, where you send the radius packet, you don't get the reply. If you do get the reply, then it's becoming a bit more troublesome and you need to start debugging SG. But often you will see it's sometimes very stupid, like a radius packet not being sent. It's a P1 because the radius doesn't reply and nothing is coming up. Obviously, they might even not see it for days. If they have a specific server to authorize the services, and suppose they use this line, but to another group, and somebody is actually dealing with that radius for service only. He doesn't care about logging of user because that's another department. He just defined the services. And for some reason, he didn't restart that server correctly, and the radius server here is done. But since ISG cache, there's no problem. And then it goes there for 1, 2 weeks, 3 weeks, no problem, because we still have the cache. And then the ISG crashed for some reason, and then nothing comes back because the authorization is actually not successful. And then he says, but actually I had a problem with BGP. Then you think, oh, probably it's a routing issue. But actually it's just because his radius is actually done. And it was done for already a few times. But he didn't notice because everything was cached in the ISG. So step 1, like I say, I'll just repeat once more, run the subscriber, see what he does. First step, is it successful? Second step, is it successful? What do you install? Is the service correctly assigned with the correct class traffic? If you need to treat the traffic. If it's something else, like maybe PBHK, maybe you don't need to have a class. But every time, step by step. If you have a very complicated policy control, it would be nice to even remove the line. If nothing works and everything is done and you don't find really the problem, maybe you can start by configuring the first line. Obviously, if you only have one, you already know what the problem is. But if your customer has multiple steps here, why not just doing, for example, Open Garden, if he has a service Open Garden that gives some basic service. Is it coming up with Open Garden only? Maybe then the problem lies in the other installation below. Suppose the customer would have like 5 entries to enable the service, and he does it all locally. And he calls some lines here, step 1, enable that service, step 2, enable the service, and so on and so on. And then he forgot somewhere an access list assigned as a traffic. You will not bring any users because the last one will try to install the service. You'll find out incomplete because the access list is missing in your config, and he drops everything. And then you can search, but the easy way is in that case really do step by step. First works fine, so it's verify. Second, third, and so on, and then you can actually really segregate the problem. But that's sometimes very interesting. So. We also talked last time about the portal. We'll do some redirection case anyway. PBHK service is a special way to recognize the users. And what do? We assign a specific key per subscriber. And why is that key useful? It's because when we send the traffic from the edge, we will use a source here with a specific range of TCP port, and that portal will understand which subscriber it is. The key that we allocated on that subscriber will be actually recalculated here in the portal with that source TCP, and it will send it back. Do you know this guy? And the SG will say yeah. Or does he send it back with COA? So the portal is aware about the definition that the ISG gave as a key. Why is it useful? It's because this user can now move from here to another ISG. Every time the portal knows only the loopback of the ISG and is sending correctly. It doesn't need to route any stuff for that subscriber. Useful in the case of a PPPoE with a fixed IP address. Sometimes we have users, subscriber like this or service provider like this. They actually distribute the /32 everywhere amongst all those graphs. And once time the /32 will be here, sometimes it will be here. But that portal cannot be adapted to every time route to this /32. So what they do, they use a loopback to represent the user, and this is done with this PBHK. And you can see here, when you enable that, you don't want any traffic class. Or even actually here, we didn't define the service, but it's the same way. You just do service configuration with one line for direction. And there's no traffic class. It's just a feature that is called PBHK. We'll do some exercise with this anyway. So I will go in details when I actually configure the lab. Then we have this redirect functionality where we have a service here with a redirect. And then we actually do this class again because we need to match the traffic. What is he going to match? HTTP packet, obviously, here. And you see here, defining that tunnel, we actually deny explicitly some addresses. That address is the one of the server because you don't want to redirect traffic that is going to the portal, because the idea is to redirect the traffic of Google and so on, not to the portal, So you don't want to redirect the traffic of the portal to himself, because that's going to be some trouble. Especially if you don't use the Cisco solution and you use a specific port, and or the 302 is done from a separate part of that server, then it's going to loop all the time. With the Cisco solution and that stuff that we bought from BroadHop, it doesn't matter because it's a URL calculate. So once you get the first time you get a new URL, they're specific for that user. So even if you match this one, it wouldn't cause too much trouble in the redirect. But normally you don't do this. Then you have this policy open garden. Again, we'll do some exercise with all of this stuff. Just going to go a bit with what we saw last time, I think, definition of service and so on. Maybe before we do a break, I will try to get to that page here just to review again the different steps to try to understand a case actually. Or maybe I could take a case on the topic and try to understand what they do. We'll do this when we have done the lab, so you have a bit more information. So what I was saying last time, when you have a session control start, and here is an example where you will install different stuff. And you see you're doing like 5 different steps. What if the step here actually failed and the session dropped? Or what if this step failed? Everything is dropping all the time, so maybe it could be interesting to install only this. Is it useful in this case, PBHK? No, because it's just a feature to redirect, so we will not really see something in the traffic, but at least the session would be learned and installed. Maybe it would be more interesting to go to that step. Open Garden service is like a free service. What do the user usually do this? Is because they want to give DNS service or some basic access to portal or some of their own HTTP server. So they call it Open Garden because historically, when before ISG, we had SSG, and the SSG added the feature Open Garden for those type of free service. So that's why that name just came with ISG, but you could call it free service. That should be just the same for ISG. So assume you can actually install those 2 services or those 2 features. In that case, you already know you can learn the IP subscriber, you can install a session, you can install at least 1 service. You're already far, as opposed to not having any subscriber at the time. Next step is obviously to test this line, and now we know we are gonna actually send a radius. What is this auto? This one is to send a radius packet to the radius server. Is it really matching something? Because when the customer configures it and if it's not there, the IOSXE will complain that the list is not there, but it stays in the config. So since most of them copy and paste and never look at what the result of the config is, the line will be there and nothing will work. It will verify the config as usual 20,000 times, and everything was configured like it was asked to configure it. But obviously he forgot to configure AA, but that he didn't check because it was not his own responsibility. So obviously, next step is to open the P1 because nothing works. So here we need to verify that AAA line is actually there. If it's not there, you already found the trouble. Is it something wrong with this? Might even be that the guy is not actually sending remote ID, circuit ID in the CDGP packet. Sometimes you have this trouble when people actually complain that the ISG is not using remote ID, but actually ISG never got it because it's coming from the GCP and it's a device in between this ISG SR1K, then needs to insert it. But since it was not inserted, it was impossible for ISG to obviously invent one. So, but they will open a case with ISG for sure. So we can verify this by debugging the GP, sniffing or whatever. You will see if this option 82 is actually there in the GP packet. Once you have done it, next step is obviously to send the radius packet. Is the radius packet arriving? Do you get a reply? Do you get the reply that you actually want? Maybe install another service or internet service or whatever. Is it supposed to be accept? Because now I see the next line is actually to enable L4 redirect. What would that mean? I mean, here I authorize, but then I will install L4 redirect. This is specific case in ISG. Once the authorization fails, you can still go to the next step. And then you install here, in this case, L4 redirect. If the authorization would be successful here, on step 30, you will not execute this one. So you will leave it there. And the session start event will actually be terminated. I mean, inside of ISG, he completed whatever you wanted to complete. And then eventually there will be another event for that session. But right now, since we did an authorization, it was okay. So here we have, suppose you don't have, you have this L4 redirect that is being installed. Obviously, we need to find out if the service is defined correctly. If it's not, you find another trouble. And then you assign a timer to that session. So the session that is now created as Z has also a timer assigned to it. What is the purpose is that when you actually pass the 5 minutes that is here, there will be an event in ISG saying, oh, this timer expired. And then what do you need to do with it? So far, nothing, except you actually configure something. And the configuration is actually here. An event, timer expire. Yeah, this is probably going to happen after 5 minutes. And what does it need to match? It needs to match this part. What is this? It's a type control and class type control. So it should be a class map type control somewhere in the config with the exact same name, which is here. And what does it need to match? It needs to match a timer name IP uno timer, which is actually this one here. So is that timer that expired? Yes. And then what is this? Is subscriber is still unauthenticated? Yes, it's our case. So in that case, we actually close the stuff and we go out, because here you have the service disconnect. What is it used for? Because you don't want the subscriber that don't have an authorization to come back all the time and hammering the 1K with a lot of control plane for ISG. So you leave them there for 5 minutes. Maybe in the meantime they access the portal. Maybe they don't. But anyway, they don't cause too much trouble because they're not coming back every 100 milliseconds with the DHCP and reinstalling everything. So that's really useful for CPU purpose. This stuff. Let's do the rest and then we'll do some break. Here you have an event account logon. What is it used for is when the portal will send you a change of authorization that is called account logon, meaning the subscriber went to the portal of the service provider, entered his credential and did something, maybe say assign a service or whatever. And the portal scientist smart is checking in the ISG if that guy is really there. If we use PBHK, we use that specific TCP port that was received on the portal to calculate the key. Comes back to us, say, do you know the subscriber? ISG says, yes, I know. So we send it back. And then the portal sends an COA account logon. And obviously, we face that event. What is happening with this? We actually need to authenticate this time. Is it possible to authenticate? Because we remember we were using only remote ID, circuit ID in this phase. But here, we actually get a username and a password from that portal, because that's going to be the username and password that the guy actually entered in the portal when he was accessing it. So we have a real username and a real password. So we send an authentication now. And we use list attend list 1, which is normally configured with AAA login. So authentication login. You should see a line like this somewhere in the config with the exact same name. If the AA authentication login type is not configured, this will fail. You will not look for something else. Once he assigns a username and password to the Radius server this time, Radius server return an access accept, hopefully. If it fails, you can still have some event for access reject. If it doesn't fail, he actually gonna do here, disable the L4 redirect. So we remove the L4 redirect pipe of that subscriber. So no redirection function will be needed anymore for that subscriber. And so in that phase, you could see the username changing if you do show subscriber session. Because on that first phase, you will see an IP or this remote or this MAC address if you do show subscriber session. If it gets authenticated, that same user will actually change and you do show subscriber session. You don't see the MAC address anymore. but you would see the name. So sometimes you're looking for something and actually everything is working fine. So here you have a disable forward direct, so at that point I suppose the customer would be actually active. And this is each step. And again, like I was saying before, you can actually remove those lines if everything is done, you know. Even if, suppose you only have one user affected, you could still remove line because the other one have already the session established. And if the customer can guarantee you, yeah, it's not a problem, they will be stable, and that's only a unique subscriber is getting with the trouble, you might still remove the line because you will not affect the other ones. Obviously, if you start changing on the interface, that might get a bit more trouble. Or if you start clearing or disabling services that are cached, you might have a lot more trouble. But potentially this is only used when the session starts. So you could still change, even though maybe you have case of a account logon later on, assuming the subscriber went through the session start already and is in a phase of waiting this timer, but within the 5 minutes he was actually doing the logon, and within those 5 minutes you remove some line, it might still work because you would go to this account logon and it was already past this session start. So you have a lot of possibility actually. So what I will do before going to this ISG prepaid feature is explaining a bit the lab, what we're going to do with the lab. I don't know many people are actually in this session. If there are people from India, we can also, you will have the same type of device on that in Bangalore. So we can actually create users and you can start playing a bit also following what we do. I suggest you do because I will sometimes pick a guy to find out if he is okay with the config or to check his config, because you will have trouble for sure. Sometimes it will be a stupid config that we forgot, and don't be ashamed. It happened to me also. Those subscriber service authorization, it happened to me. So that's why I was telling you about. So, but it's interesting to troubleshoot because at the time you troubleshoot, you will actually understand what you need to look for and the steps and everything. So let's do some break, and so we can stop this recording. And then we will start talking about the labs that we're going to use in the next session. Maybe at the end of that one, you give me a number of users so I can configure them in the machine so we don't lose time with that. And then next time we will start maybe configuring basic stuff. Okay, so I don't know, you can stop this recording for now.
Let me stop the recording.